So, in summation, Geometry Dash, basketball, and Fortnite are like the three worst inventions that have ever been made in humankind. All right, so, yeah, no more talking about Ronaldo since he's not here. We weren't really talking about that. Felt too mean. We're too far. All right, check it out. Given any convex, and we're just making sure that that's included, and I will write much larger because I can already feel I'm writing small. Given any convex, just means pushed outward, n-gon. The sum of exterior angles is always, how many degrees? 360 degrees. Every single time. Now, we are going to write a proof for this one together because it's not going to be the nice traditional two-column proof. And like we can use it and try to set it up the same way, but we're just going to have to logic it out a little bit. And this proof is different, but we're going to get through it together. I took it off the homework assignment so that we could do it as a whole class because it's a weird one. Now, if I said prove this for a triangle, it'd be easy to do, right? Because you have three exterior angles and you know that they're always supplementary. If I said do it for a fourgon, it would be easy to do. You would just have to give me the fourgon and you just have to write them all. But if I say do it for an n-gon, do we have a specific picture that we can look at?
No.
No, we're just trying to do it in the most general case. So we're going to try to logic our way around, and we're going to try to prove this one. And again, we always write two-column, right?
Yeah.
But this one might not be, but that's okay because we're doing it together. So I want to prove this, and we're going to think about it. And we might draw a part of a picture, but we can't really have a true picture because the same theorem works for a 3-gon, that works for a 20-gon, that works for a 500-gon. And it's a weird idea that we can't just have a singular picture. But we're going to pretend like we could. Okay, so if we're trying to prove this, we're just going to make some statements real quick. If you give me an n-gon, and we're just going to write like little bullet points. We can do A and B if you want. An n-gon has how many exterior angles? N of them. So a 3-gon, a triangle, has 3 exterior angles, right? So whatever number of sides, we have that many. An n-gon has n exterior angles. Are we all agreed with that one? Now, it doesn't matter if my n-gon is a regular n-gon or not. Do you think it gets easier if we let it be regular? Which just means all the angles are the same on the inside.
Yes.
Yeah.
Like, if it works for a regular one, that idea can expand to a non-regular as well. It's just going to be nicer to work with. So on B, we're just going to say a regular n-gon. And what does it mean for regular again?
All sides and angles are the same.
All the sides and the angles are the same. A regular n-gon has a single interior angle of what? How do you find a single interior angle of a regular n-gon? And I love what Eli's doing here, Elijah. He flipped his notebook over for some reason. Why did Elijah flip his notebook over? We have a corollary to a theorem that we might be able to apply here. I want to find, for a 7-gon, we could find what each interior angle is. How?
N minus 2 times.
N minus 2 times 180 gives me what all the angles add up to. And then we have to cut it into n equal pieces. So we have a formula for this via our corollary from yesterday. If I want to find a single interior angle, it is always going to be given by n minus 2 times 180 divided by n. Okay, it is ugly right now for just a second. We don't have a real true picture that we can draw, but we have a generalized picture that I can think about. I'm only going to think about one little part of any random n-gon. So it is entirely up to you if you want to draw this part or not. But if right now we're looking at just one interior angle of it, right? So let's just think this out here. Let's say that I have this part of a bigger polygon, and here's an interior angle. What we have just written down is that this angle turns out is exactly n minus 2 times 180 over n. This is all that we've done. We've written that part down. Do I have any questions here? Right, Henning, I see you going like, whoa, what do you mean? Have I lost you, or are you just trying to make sense of this? Okay. We have n exterior angles, and I'm fine with that. And then this is just a formula to find one of the interiors. Now, if this is an interior angle, if I wanted to just sketch it, and this picture is weird because it doesn't really apply to any specific thing. Here's my exterior angle, right? And what do you want to call it for now? We don't have it yet, but we could probably find an expression for it. Any unknown value here. I would avoid n because n is also written here. X is a more natural choice. I'm going to just, on this proof, and again, it's not a regular 2-column that we normally do, but we're just trying to really, really focus on the logic. I have a big question for you. If I took x plus this mess here, n minus 2 times 180 over n, which is just these two, right? What should that always add up to? Don't shout it out loud right away. I want you to quietly, so that not everybody hears you, talk with your neighbors. I want you to tell me that if we add up these two angles, what should it add up to and why? So I like your answer. I want to know why.
I think 180.
What do they form when you put them together? I don't know why that would be. Okay. What do you guys think? It's weird when we look at it, but forget about all that. I have an interior angle and an exterior. What do they have to add up to?
Let's call that,
I'm trying not to get confused. But forget about all this. When you put those together, these two angles. Like, forget about the stuff that we have on it. If I say here's an angle and this one, do they form a straight line together? Does this and this form a straight line? Yeah, and what's the straight line add up to? Boom. Did you know that, or did you hear that and just repeat it? So every time, like, a straight line is like halfway. And that's, if you know that a full spin is 360, half of that. Because it might not be the easiest way. Okay, coming back together. I don't have my microphone on. I have no idea where I'm recording. What do these have to add up to? 180. Why? These form a straight line. Now, it doesn't matter if this is a real picture or not, right? They always will form a straight line like this, an interior and an exterior angle. Okay, now here's where it gets kind of ugly. I need to show that all my exterior angles add up to 360. That's the whole goal here. How many exterior angles will it have? Any n gone. It'll have n of them. So if we look at this, if I want this to be one exterior angle, could we solve it for one exterior angle? And I'm just going to make this here 1, and this is way wordier than I would normally do it. One exterior angle is, and I want you to, this is really quick, we don't have to do a ton of math right this second. Can I solve this equation to make it so it's just x on the left? Minus this awful thing, right? We're just going to subtract this number, whatever it is, from each side. So I will just write it's 180 minus n minus 2 times 180. And it gets ugly for a second, but as long as we just let it stay ugly, we'll make it nice here in just a moment. All I've done is rearrange. If this is true for every exterior angle, then if this is a regular polygon in our nice example, this is what each exterior angle should be. We're trying to show that this is always going to be 360 when I add up all these x's.
Oh.
Yep, so I'm sorry I didn't write the show statement. It's because I don't normally do this. We had the theorem presented, and I'll just show you here. We had the theorem, and then this is my proof. Yep, so no, that's my bad. I should have been more specific with that. Bless you. So I need a way to say that when I add up all these x's, it's 360 for any number of x's that we have. Well, that's one exterior angle, right? And I asked this question a moment ago, but how many exterior angles will this n-gon have? So if I wanted to add this up, x plus x plus x n times, is there an easier way to write that? It's not to the nth power. That'd be x times x times x. What's repeated addition? Like I could do 2 plus 2 plus 2 plus 2 is 4. Or sorry, it's 8. My bad. But that's the same as doing 2 times 4. Right? We just multiply. If there are n exterior angles, I can add this up n times, or I just multiply by n. Everybody okay with that? Now, that's using this first statement again, right? An n-gon has n exterior angles. If this is one of them, then we can say on step E, then n, and I'll just multiply the left side by n. But in algebra, and I'm going to change color so it's more clear. In algebra, if I multiply the left side by n, what else do I have to do?
Multiply the right side.
Let's multiply the right side by n as well. And it looks awful, I assume. Do you guys think it looks awful? It's about to get so nice. I think Elijah might have just had the eureka moment. Maybe. Okay. What does, if each exterior angle is x, nx then represents what?
Sum of the exterior angles.
This is the sum of all of my exterior angles. That's what this left side is. Well, let's clean this up real quick. You may look at this and kind of panic with the algebra. It's okay if you panic as long as you try something still. Gian, when you see this last expression, I'll come over here so you can see it. Only on the right side, is there any algebra that you see that goes, yeah, I might try this. Whether it's right or wrong, I don't care. What might you try? Okay, so I'm going to make you be more specific because I agree with you, kind of. We're going to do the math part of this. What's happening between all of the stuff in parentheses and this n? I'm going to give you multiple choice. Are they adding, subtracting, multiplying, or dividing? Why?
10 minus 2, 180.
So I agree with you. I do see division, but let me be more specific because me pointing maybe doesn't help. What's happening between this piece inside the parentheses and this piece outside the parentheses? Good. And we're trying to multiply one thing into two, right? Distribute. Let's do that. Help me out with this. On this side, I'm going to keep my nx. I'm cool with that. Kevin, what do I get if I do this?
180.
180n. Okay, this is totally optional, but I want somebody who hasn't spoke today. What happens when I do this one? It is so much easier than you think. Clyde.
N minus n squared.
You could do some really nasty stuff, right? I don't hate that idea. Akis, what do you think though?
N minus. Wait.
So you're trying to distribute it to everything, right?
Yeah.
Real quickly, just with this piece, what is it being divided by?
N.
And we're about to multiply it by. Do you agree that we are multiplying and dividing by n? What do? They one out. N over n is just 1, right? So we could distribute it into everything, which is awful. Or we could just realize that it's just left with this. N minus 2 times 180. These would divide out on that multiplication. If you didn't see what I said, these would divide out. It's this n is being divided by this, and I would just cross those two out. Cancel is the bad word that I don't want you to say, but that's what's happening, right? Cool. All right, I want you guys to go one step. One last step. I just want you to play the algebra game. Just clean this side up. And I want you to tell me this nx, which we've already decided right here is the sum of n exterior angles. And I'm just going to say all n exterior angles. And I want you to clean up this side. Just do the little distribution, and I want to see what we're left with. I'm going to give you guys like 30 to 60 seconds, and let's see what shakes out of it. All right, so if you're struggling with it, I'm going to start talking through it here. It's weird to see sometimes, but this is distributing through still, even though it's on the right. Like, it's odd to see it that way, but it does the same thing. If we look at this side, I still have my 180n, and I minus, what is this one going to give me? 180n. And I can make that 180. And then this one is going to give me a minus a negative, which is weird. Minus a negative 360. Which, what happens to that minus that negative? They change to plus, right? Anything fall out? You say no. Are you sure?
Yeah.
180n minus 180n. And we just found that no matter how many sides or how many exterior angles, any number n of them, if you take all the exterior angles, what do they always add up to? And look at that. Quad. You rot.
Dingle. Oh.
Demonstrandum.
Quadil dingle. Quadil dingle. Quadil dingle.
Not a clue what you're talking about. All right. So here's the good news. I'm not going to make you guys do a proof like this on your own, just so you know. We did the very most generalized case. I don't know, after seeing one of these, maybe you guys could emulate something similar to this. Could you follow logically what we just worked through? So if it's anything but straight no, I think it's okay, because this is pretty abstract stuff that we're trying to do right now. It's pretty far out there. Okay, with this, I want you guys to have like 20 or so minutes. I want to give you an assignment to start working on. If we have time to get a little head start on tomorrow's stuff, we'll take advantage of it. If people aren't working, I'm not going to give you any time for it. We'll just start the next lesson. Cool. So, just as a reminder, on homework assignments for me, if here's your page, I want you to do it, one, not on the back side of your notes, so that if you have to rip it out, you can hand it in. What goes in the top left?
Name.
Your name. So here's me. Don't call me Kyle. Anything else I put on this front page? So I would always appreciate, because I have so many different classes, 5th hour geometry. For those of you that put the date on it, that's always appreciated, but I don't require it. And then here is our assignment for now. I'm going to give you guys homework. It looks like it is 6.1. And we will do this on page 254. And I want you guys to do problems 13 through 25 odd. But you can skip, because we just did it, number 15. Okay, for this, just in case you don't recall, how do I grade your homework?
You did it?
If you did it, right? There's no penalty for getting it completely wrong. I will go in right now and I will upload the stuff onto the classroom so that you guys have the answers, because they're not in the back of the book. I just want to remind you, somebody in here, I assume somebody handed in all the homework first semester, but still bombed every test because you didn't really do the homework. How much of your grade is homework worth? It's like 10 or 15% of your grade. If you do none of the homework, but you get 100% on it because you're getting the answers, will you be successful in here? No, definitely not. Because if you're not doing the homework, what are you going to bomb every single one of? The tests and the quizzes, which wind up for like 70% of your test, or your grade. Cool. All right. I'm going to give us 20 minutes to work. We'll do 2 10-minute increments. If people are working for the first 10 minutes, I'll give you 10 more. Cool. Without any contest, Passion Pit, The Dead South, or Chromeo?
Passion pit.
Okay.